Hi everyone, I'm Cheryl. In this problem, we're going to be using the properties of derivatives to evaluate a variety of derivatives. So let's start with part A. I want to find the derivative of my vector value function r. Well, notice I was given two functions, r and u. So the derivative of r is simply the derivative of each of the components. So I'm going to have vector I plus 3j plus 2tk. That's all that was required for the first one. So now let's go ahead and move on to one that's a little bit more complicated. I want to take the derivative of 3 times my vector function r minus the vector function u. Using my properties, I know that if I take the derivative of two pieces that are subtracted, I can take the derivative of each one individually and then combine the answers. And then this first one I notice is a constant multiple, so I can pull the constant out. In other words, by my properties, I can say that this is equal to 3 times the derivative of my function r minus the derivative of my function u. Okay, so what does this mean? Well, I have 3 times r prime of t. I've already calculated that. That's going to be I plus 3j plus 2tk. And now I'm going to subtract the derivative of my vector function u. I haven't done that one yet, but it's easy enough to calculate. The derivative of u will be 4i plus 2tj plus 3t squared k. Now I'm going to go ahead and distribute that 3. And so I have 3i plus 9j plus 6tk. And I'll be subtracting the 4i. I'll subtract 2tj and 3t squared k. I simply distributed that minus sign. And now I can combine my like terms. So I have a 3i and a minus 4i. So that's negative I. I have a 9j and a minus 2tj. So that leaves 9 minus 2tj. And I have a 6tk and a minus 3t squared k. So that's going to give me 6t minus 3t squared times vector k. And that's my final derivative. Okay, moving on. The next couple of problems deal with the product rule. Notice in this one, I have the derivative of 5t times my vector function u. By the product rule, I know that I can start out by taking the first factor, which is 5t, and multiplying by the derivative of my vector function u. Then I'm going to add the derivative of 5t times my vector valued function u. Plugging in this information, I have 5t times the derivative of u. Now I said that the derivative of u is going to be 4i plus 2tj plus 3t squared k. I'm going to add to that the derivative of 5t. The derivative of 5t with respect to t is just 5, and then I'll multiply by vector u, which is 4ti plus t squared j plus t cubed k. And now let's go ahead and distribute that 5t across. So I'm going to have 20ti plus 10t squared times vector j plus 15t cubed times my vector k. And I'll also distribute the 5 across. So I have a 20 t times vector I plus 5 t squared times vector j plus 5t cubed times vector k. Combining my like terms, I have a 20ti and a 20ti. So that leaves a 40t times vector I. I have a 10t squared times vector j and a 5t squared times vector j, which will give me 15t squared times vector j. And then for my k vector, I have 15t cubed and a 5t cubed times vector k, so that's going to be 20t cubed times my vector k. All right, moving on to the next one. For part D, I want to take the derivative of the dot product of r of t and u of t. Again, we can think of this as a product rule. So we're going to be taking r of t dotted with the derivative of u. And then we'll add r prime of t, and we're going to dot that with u of t. Okay, so now let's plug in the details. R of t, that is going to be ti plus 3tj plus t squared k. And I'm going to take the dot product of that with u prime. Now u prime, remember, was 4i plus 2tj plus 3t squared times vector k. We're going to add this to the dot product of r prime and u. R prime was I plus 3j plus 2tk, and u is 4ti plus t squared j plus t cubed k. Okay, now remember when you take a dot product, you take the product of the components. So for my first dot product, I'll have t times 4. So that's 4t. Looking at the j components, I have a 3t and a 2t. That's going to give me 6t squared. For the k component, I'll have a t squared and a 3t squared. That will be 3t to the 4th. That completes the first dot product. For the second dot product, again, I'm going to multiply components together. So I have a 1 and a 4t. So that's 4t. For the j components, I'll have a 3 and a t squared. So that's 3t squared. And for the k components, I have a 2t and a t cubed. That's going to be 2t to the 4th power. Now I can combine my like terms. I notice that I have a 4t and a 4t. That's going to be an 8t. I have a 6t squared and a 3t squared. That's 9t squared. And I have a 3t to the 4th and a 2t to the 4th, which is 5t. Now we're going to move on and do parts E and F. Now let's try part E. I'm going to be taking the derivative of a cross product. And again, we're going to be using the product rule to do this. So the derivative of the cross product will be r of t crossed with u prime of t plus r prime of t crossed with u of t. Now, one thing to be careful of is remember that the cross product is not commutative, so you have to make sure that you get these two factors in the correct order. Okay, so let's go ahead and plug in our information. I'm going to be taking the cross product of r of t, so that's going to be r is ti plus 3tj plus t squared k, and I'm crossing that with u prime. U prime will be 4I plus 2tj plus 3t squared times vector k. Then I'm going to add to that the cross product of r prime and u. R prime is going to be I plus 3j plus 2tk. And I'll cross that with u. 4ti plus t squared j plus t cubed k. All right, so now we need to take the cross products. So remember what happens. We set up determinants. We have I, j, and k for my first row. My second row will be the components of my vector. So that's going to be a t, a 3t, and a t squared. The third row will be the components of my second vector. So that's going to be a 4, a 2t, and a 3t squared. I'm then going to add it to another cross product. Again, my first row will be vector I, j, and k. My second row will be the components of my first vector, which will be a 1, a 3, and a 2t. And the third row will be the components of my second vector, which will be 4t, t squared, and t cubed. So now let's evaluate the cross products. So I'm going to start with the row and the column that contain I and eliminate those and look at 3t, t squared, 2t, and 3t squared, and then multiply that by my vector I. I'll move on to j, and again, eliminating the row with j and the column with j, I'm going to subtract the determinant using t, t squared, 4, and 3t squared, and then multiply that determinant by vector j. I'll eliminate the row with k and the column with k, and I have the determinant using t, 3t, 4, and 2t, and multiply that by vector k. Now I can move on to my second cross product. So again, eliminating the row with I and the column with I, my determinant is going to look like 3, 2t, t squared, and t cubed. That will be multiplied by vector I. Eliminating the row with j and the column with j, I'm going to subtract the determinant 1 and 2t, 4t, and t cubed, and multiply that by vector j. Eliminating the row with k and the column with k, I'm going to add in the determinant 1, 3, and 4t, and t squared, multiplied by my vector k. Now I'm going to move all of this up here. So now, to evaluate this determinant, I'm just going to take this product and subtract that one. So I'm going to end up with 9t cubed minus 2t cubed times my vector I. For the next piece, again, I'm going to have a 3t cubed minus 4t squared times vector j. For the next one, I'll have a 2t squared and I'm going to be subtracting a 12t. And that's times vector k. Moving on to the second cross product piece, I'll be adding 3t cubed minus 2t cubed, again times vector I. The second piece, I'll be subtracting t cubed minus 8t squared, and that's times vector j. And then I'll add t squared minus 12t. So t squared minus 12t times my vector k. Okay, so we're getting closer. We need to do some simplifying now. I have 9t cubed minus 2t cubed, so that's 7t cubed times vector I. This piece, I'm just going to distribute the j, make this minus a 3t cubed times vector j plus 4t squared times my vector j. I'll have a 2t squared times vector k minus 12t times vector k. Then here I can combine 3t squared and minus 3t cubed and 2t cubed for just a t cubed times vector I. Distributing, I can write this as a minus t cubed times vector j plus 8t squared times vector j. And again, distributing here, I'll have a t squared times vector k minus 12t times vector k. Okay, I think I'm ready to put it all together now. I have all the I terms that I need to put together. So there's a 7t cubed times I and a t cubed times I. So that's going to give me an 8t cubed times vector I. Now let's collect all the j terms. There's a minus 3t cubed, a 4t squared, a minus t cubed, and an 8t squared. So the t cubed terms add together to be a minus 4. So let's add a minus 4t cubed, and this will give me 12t squared times my vector j. Now I need to combine my k pieces. So here's 2t squared minus 12t. There's a t squared and another minus 12t. So the t squared terms add together, and I get 3t squared. The minus 12t and the minus 12t is a minus 24t. And that's all times your vector k. And that's the derivative of my cross product. Okay, one last one. Part F. Part F, we're trying to take the derivative of my vector value function r that's composed with 2t. This one is going to require the chain rule. So we know that when we take the derivative using the chain rule, we'll be taking the derivative of my vector valued function and composing it with 2t. Then I need to take the derivative of the inside function with respect to t. So we're going to multiply by the derivative of 2t. Okay, so we want to evaluate r prime of 2t. Let's just remember for a minute what r prime of t is. So r prime of t is going to be I plus 3j plus 2tk. So I want to evaluate this derivative when the input is 2t. So when the input is 2t, notice that I just have I plus 3j plus 2 times 2t. So 2 times 2t times my vector k. And then this entire vector gets multiplied by the derivative of 2t, which is simply 2. So distributing the 2 across, I have a 2i plus a 6j plus 2 times 2 is 4 times t times 2 will be an 8t times vector k. And now I have the derivative of r of 2t. I hope that was helpful. Thanks.